question 17?
T days. Oh no.
Yes or no?
It's a no.
It's a no. Okay, why?
I think it's very intimidating.
Well, what does the question say?
Oh, okay. So, T days after, and they've given us after 15. Is that? Oh, that must be days. So, do you just replace the T? So it's 15 equals, and then you just work it out.
Exactly.
Okay.
Okay, so insert.
Hold on. Are you sharing?
Oh, yeah, sorry, I forgot to...
No worries.
I'm writing down on the thing already. Let me quickly do that. Okay, there we go.
Okay, I can see.
Okay, insert T equals 15.
Okay, so...
That's all. Okay, because they told you the number of people contracting the contagious disease T days after the epidemic.
Okay.
Right, so 17 is just asking you, do you know how to use your calculator? That's all. Okay, so do you?
Try. Well, I would have taken the long way to calculate
Doesn't matter.
it.
Long way, short way, anyway, as long as you get the right answer.
So, let me just quickly... So... 12. Ugh. 1, 2, 3. Divide by 2. Divide by 2 plus 1249 to the power of minus 0.33. Ugh, how do I do this? Let's put on a bracket there, I think. Minus 0.33. Bracket 15. Let's see what the... Oh, nope, it doesn't work. So, do I first work out, so minus 0.33 times by...
Okay,
15.
did you type it all in as one sum?
Yes, I did.
Okay, maybe work it out separately then. Okay, so on your calculator, do you know where the E button is?
We didn't use, I think we used the little cuppy. There wasn't an E.
No, that's the exponent. We didn't use the E. The cuppy key you talk about is the exponent. Let me put up the... oh yeah, you gave me the link in the Skype message, right? Let me just get that link for the calculator. Where was that link here now?
Oh, that's the E over there.
Yeah, it's still here in the chat.
Oh, I've got it. Okay, I found the E.
Oh, did you find the E?
I did.
Okay.
Plus 1249. I think it's Shift E.
Where's your E?
It's there by the N. Next to the log.
Next to the log? Yeah, it's a shift though. It's by Lynn. It's the shift. So you press shift and then the E.
Okay.
Shift and then that button and the E will pop up on your screen.
Okay, and then what do I do? Do I just type in minus...
Well, it should put a, does it open a bracket?
No.
Okay, then if it does, and then open up your own bracket, and then put in that negative times the T.
49, shift.
Yeah, the minus 0.33 times T. Close that bracket.
Minus 0.33 times, what was it, 15?
Yeah, T is 15.
Okay, so I get 10.847. So 460, yeah, it would be 461, yes.
There we go.
Okay. Okay, wonderful. Yes,
so
okay, so we like that question.
You should like questions like that. You should be hoping for questions like that.
Okay, so
because
then...
it requires nothing other than interpretation. Okay, so you have to interpret this question correctly. you needed to know that this was the days and that was the time, and then this thing will give you the answer.
Okay.
18 is a bit more challenging. Why?
18 after how many days rounded to the nth with?
You're working backwards. Okay, so now they want to know what the days are, which is the T. Do you agree?
Yes.
You've been given the number of people contracting the disease. So you've been given this, the Q. So I'm going to write down 1,000 equals 5,000 over 2 plus 1249 e to the power negative 0.33 t. Now I need to solve. How do I solve? I'm going to take all of this stuff at the bottom here, move it to that side, take this stuff on that side to this side. Okay, so I'm going to have 2 plus 1249e to the power 0.33 t equals 5,000 divided by 1,000 is 5. Do you agree?
Okay. Yes, I do.
Okay. I'm just going to move up to there. Okay, so now we're going to have 1249e negative 0.33 t equals. Okay, take this 2 to that side, becomes minus, so I'll have a 3 here.
Yes.
Okay, so now I need to remember something basic, this. Okay, I need something to work with. This is what I remember, so I know what to write down. Okay, so what does this mean? This means I have a base to an exponent equals an answer. So if I have a log, I'll have log the base of the answer equals the exponent. Okay, so I'm going to apply this to what I have here. Okay, so what do I want? I want the exponent. So what is the exponent? Negative 0.33t. Okay, so if that's the exponent equals this. The log of the base times the answer. So what is my base? My base is E. Okay, and my answer... Oh, I forgot this bit over here. This bit needs to go to the other side.
Okay.
Okay, so that'll be... let me just rub it out rather, it's easier. Just rub out that number there. Okay, so it's going to go on this side. So 3 divided by, what was it? 1, 2, 4, 9. Okay, and on this side we'll just have E. Okay, so e to the power negative 0.33t equals 3 over 1249. Okay, so I've got the exponent. There's my exponent. Okay, there's my exponent. Is going to equal log base of the answer. Okay, so what is my base? My base is E. So it'll be log base, which is E, of the answer, which the answer is that 3 over 1249. Okay, something else to remember, log base E is ln. Okay, so remember on your calculator we were talking about the E, and you have to press shift, the ln button. You saw that button on your calculator, ln?
Yeah.
It means ln. Ln is just log base E. E is a constant.
Okay.
If you press e to the power 1 on your calculator, it gives you a constant. It's like any other constant in mathematics, like pi. Pi is a constant.
Okay.
Okay, e is a constant. It's just a mathematical constant that recurs in different calculations.
Okay.
Okay, so log base e is the same as ln. Okay, so this answer is then going to be negative 0.33t equals ln 3 over 1249. Okay, and then to get t, I need to divide that by negative 0.33. Right, on your calculator, type that in and see what you get.
Okay, so let's try this. In Lin, I would say in divide by 1249 equal to why did I do that? Means 31 divided by what's it? Minus 0.333 equal to 18,1.
No, 18,27.
Maybe I did something. Let me just do it again. Sorry. Ln 3 divided by.
It's 1249. Yeah, it is 1249.
Equals divide by 0.33 equals 18.27.
Yeah, that's right. 18.27.
Okay.
Okay, so 18.27, which would be what? Option 2.
Okay.
Okay, so after 18 days, 1,000 people would have contracted this disease.
Okay.
Makes sense?
Yes, that does.
So a little bit tricky because you have to work backwards. The key is that. That's the key. Writing down a simple log, knowing what that log means or represents. It's base exponent equals answer, so log base answer equals exponent. Then I can just relate what I have in the question to what I have here, because I can literally just pull the numbers through.
Okay.
Okay, do you like 19?
I preferred 17. Sorry, but
Is
yes,
19 easy or difficult?
Oh, we're looking at 19. Sorry, I thought we were talking about Jeez, it's
what is 19 asking you to do?
We did this something similar, I think, last time.
Yes, it's interpretation. It's can you turn the English into maths?
Okay. Yes,
Okay,
we did
so
something similar.
I actually want to ask you to try get the right answer, because it's just interpretation. You're reading, you're interpreting, and then you're creating a set of inequalities. Right, so I do think you should be able to do this one. I don't think you'll struggle with this. Try.
Okay.
Read it and tell me what you're going to do.
Well, can I write down first?
As you read it, tell me what you're thinking.
So, furniture manufacturers, dining room tables and chairs. A table requires 540 minutes for assemble and 180 minutes for finishing. So that's table. So it's A. Then B requires 150 minutes for assembling and 60 minutes to finish. Okay, the number of hours available. So it's how many hours do we have available per week for assembly is at least 150. So we've got 150 hours available for assembling, and we've got and for finishing it is at most 100 hours. So we've got 100 hours available to finish. If X is the number of tables, this is X, and Y is the number of chairs.
Okay, just a quick question. Are you happy with the units of measurement?
No, they're giving minutes and hours, hey?
Exactly, that's important to note.
Okay, so we need to convert that. Oh, do we convert it? I can't remember now.
Yes, you have to. You can't work with minutes and hours.
Hours.
So which one are you going to work with?
What have they given? I guess with the hours.
Yes. Okay, hours, because they tell you how many hours are available for assembly and for finishing. Okay, those are the number of hours available. Right, so we are going to be working in hours. So how do you convert minutes to hours?
Divide by 60.
Good. So which equations are we going to have?
2.5 hours. That's 1 hour. Okay, so it's going to be 9x plus 2.5 shouldn't be should be less or equal to 150.
Less than or equal to?
Shouldn't it be less than 150 hours?
What are you focusing on, the assembly or the finishing?
Well, if you look at the assembly.
So what did they say about the assembly?
A chair requires 160 minutes for finishing number of hours per week for assembly is at least 150.
Okay, at least. What does at least mean?
Oh, it has to be greater than 150.
Yes. Okay, what else?
Greater than. And then I just want to see, and for finishing, it is at most. So it cannot be more than 100 hours for finishing.
Fine, happy with that. What's the X and Y for that one?
For finishing. It's going to be 3 and 1. So 3x plus y.
Exactly. Must X and Y be bigger than 0?
It must be smaller. No, it cannot be. Yes, it has to be bigger than 0.
Yes, you can't manufacture negative chairs or furniture. Right, so which option? 1, 2, or 3?
Greater than. Sorry, I'm looking at difference. So let's see. So it's 2.
There you go.
Perfect.
Okay. Right, question 2.
20.
Oh, sorry. 20.
Okay. If the roots of a quadratic function are 3 and minus 2, the coordinates of the turning points are...
Okay, what does roots refer to?
No, don't. I've got this. Roots are x-intercepts.
Exactly.
Am I right?
So the x-intercepts here, 3 and minus 2, so x equals 3 or x equals minus 2. So I need the function. Okay, the function would be x minus 3 and x plus 2. Right, so if I multiply that out, I get x squared minus 3x plus 2x minus 6. That gives me x squared minus x minus 6. Do you agree?
Yes.
So that's the function. What did they want me to work out?
Quadratic function.
The
turning points.
How do I work out the turning points?
Over 2a, yes, okay.
Okay, so what is b?
B is 1.
Minus 1.
Minus 1, sorry.
What is a?
A is also 1.
So, a half. Right, so you've got the x value of the turning point. Half or negative, half or 0.5.
Okay.
Negative times negative is positive. Okay, so we're either looking at this option or we're looking at that option. How do I get the y?
You just plug the x into the equation and make it equal to 0.
No equal to 0, you're working out an answer.
Okay.
Just plug in. Half squared minus a half minus 6 is what?
5 squared. That's plus 0.5 minus 6 equals minus 5.25.
No, I get minus 6.25.
Maybe I did something wrong.
Just double check.
Plus 0.5 minus 6. No, what did I do wrong? Oh, sorry, I took a minus and a minus. You're right, 0.5. Oops. 5 point... No, what am I doing? Sorry, I think I'm working too quickly.
Half squared minus a half minus 6.
Minus 6.25.
Yes. Okay, option?
There we go. Okay.
Okay, that's 20. Okay, 21. Focus here.
At what price is revenue at maximum? So if we're looking at maximum, then we need to, is it derivatives again?
Get a derivative. Good. Okay, so they want to know maximum revenue. So before I can work out maximum revenue, I first need revenue. What is revenue? Price times quantity. What is the price? P. What is the quantity?
90 minus 1.5p.
Okay, so revenue is 90p less 1.5p squared. Give me the derivative of this.
It's going to be 90 minus what's it, 2 times 1.5, am I right? So 90 minus p?
Minus 3.
Minus 3p.
Okay, 2 times 1.5 is 3.
Okay.
Okay, and then
yes,
what?
Got it.
Oh, hold
so
on,
now
90. I wrote 9. Left out a 0. 90 minus 3p, yeah?
Okay.
Then what?
So, at what price is revenue at maximum?
Derivative equals 0. So 0 equals 90 minus 3p. 3p equals 90. What is p equal to?
30.
Yes, there's the answer.
Oh, nice. Okay.
Okay, so here they wanted you to find the maximum. Okay, what is the maximum price? Derivative equals 0, solve for p.
Okay, perfect.
Okay, 22. What's the focus here?
Find the producer surplus at market equilibrium.
Okay, so if it's producer surplus, which way is the graph sloping?
Producer surplus.
Who produces? The supplier, right?
Yes.
Okay, equilibrium is going to be
P is equal to Q.
P equals 90. They said where P is the price and Q is the quantity, find the producer surplus at market equilibrium. Okay, so market equilibrium is going to be somewhere over there, right? Okay, so they want you to find the area under the graph. Okay, so market equilibrium, the price here was 90. This value here is 50. I just need the quantity. Okay, so what's the quantity going to be? Well, when P is 90, so when P is 90,
Q is equal to 20.
Q is 20, right?
20, yes.
Okay, so what's the area under the graph? How do I work out area under the graph?
Half is a half base times height.
Yeah, so what's the half base times height going to be? What's the base?
Our base is 2. Am I wrong?
20.
A 20.
What's the height?
It's 40.
What's the answer?
Times 20 times 20. 400.
There we go.
Oh, okay.
Okay. Right, and now we've even done 22 questions, so now you've more than passed.
It's so much easier when someone else is explaining. Number 23 looks very intimidating.
It looks quite hectic because it's applying those rules for differentiation. Okay, so yeah. So derivatives can be a bit challenging when they give you that. Okay, because you can see there's an e to the power q here. Okay, and they say find the derivative. Alright, so here you need to refer to the textbook. The pages I gave you last time are the same pages I'm going to use here. The derivative stuff comes up on page 335. They give you the function and they give you the derivative. Okay, so just to recall that, let me write down the rule that we're going to use here. Where is it? Okay, there's it. Okay, so they give you a table that has this and this. Okay, so obviously this is function, that's derivative. Right, they write down e to the x is the function. What's the derivative? Exactly the same thing. Easy, hey? We don't have to worry about it. Okay, and then the other bit is also important. When you have this, e to the ax, okay, then the f of x, the f dash x becomes a to the e ax. Okay, so that's a little bit different. Okay, and there are other ones as well. They give you ln as well. So the function, if the function is ln x, then the derivative is 1 over x. And they've given you the power rule as well, which is straightforward, which would have come up long ago, earlier in the chapter. Okay, so that's just the theory that they give in the textbook. We now need to apply that here. Okay, so looking at question 23, we're focusing on applying the rule, and we're trying to find the p dashed q. P dash q is the first derivative. Okay, so equals. What's the derivative of 15?
It's 0.
Yeah, there is no derivative for 15. It falls away. Okay, then I've got this thing here, which is the minus q to the eq. Okay, plus q to the squared, or q squared over 2. Right, so we'll discuss the minus q to the eq just now. Let's first do the last bit, which is a bit easier to derive. Okay, obviously you can probably find the derivative of this quite easily, right?
So it's 2q
over 2. Okay, you can't forget the half. The half is the constant. So a half times 2 is 1. So you're left with q. Okay, so there's the derivative for that end bit. Okay, so we're looking for the derivative of q e to the q. That's what we're looking at. Okay, so if I'm looking at the derivative, I need to look at what here? I need to look at that rule that, where did I put that page? Oh, there's, okay, 335. Okay, where e to the x, okay, is your function, and then you've got ea to the x. Okay, do I have a constant out here?
Isn't it q?
Yes, I do. I've got a constant which is q. Okay, so if I'm going to be deriving this, I need to apply that rule. Okay, so when I have e to the x, the derivative is e to the x. Okay, so here I've got minus q to the e to the q. So if I've just got e to the q, the derivative would be e to the q. So I'll be left with minus e to the q. Minus the q, okay, e to the q. Okay, and then I've got the other part, which is the q. Okay, so if I've got the q is what I'm deriving. What is the constant of q minus e to the q minus e to the q. Right, plus q. Right, there's the derivative. Okay, so we're applying that rule whereby when we have this, e to the x equals e to the x in terms of the derivative and the function. Okay, if I have a constant outside, so when I have something like this, 2x squared, then I have 4x. That's the derivative. I'm timesing that into there. Okay, so when I have this, I'm taking out a q because I had q here as the exponent. Right, so when I first derived this, I landed up with what? E to the q, and the constant stayed there. Right, then when I looked at the q, because now q is the base that I'm focusing on, then I'm going to be deriving this, so the constant would be the answer, because the 1 here, remember it'll be q1 minus 1, which is q0. q0 is 1, so your constant remains. Okay, that's what you've got. So if I factorize this, I can take out e to the q as a constant, then I'll have q plus 1 plus q, which is option 1.
Okay.
Right, 24, do you like?
You're definitely better than 23.
Okay, yeah, a little bit better than 23, because 23 was testing a very specific rule. The rule's on page 335. Okay. Obviously here, you can deal with this quite simply by doing what?
Well, first you have to simplify, am I right?
Yes, make it look better than it currently looks. Okay, so can you derive that?
I can try. So, is it going to be, would it then be, oh, because you always, would it be minus 5?
Yes.
X, because that would fall away, plus...
No, that wouldn't fall away.
Oh.
What does the rule say?
Well, I just, you take, yeah, minus 1 though.
Yes.
It'll be minus 2.
There
okay.
We go. That's what the rule says. The rule says minus 1 from the exponent.
Okay, so it's minus 2 plus 3.
No.
Kind of, okay. So times 3 times 5 over 2.
15 over 2. 3 times 5 is 15.
Okay.
And then what does the rule say?
It's 5 over 2 minus 1.
Which is what?
Well, that would be
3 over 2, right? 5 over 2 minus 1 is 5 over 2 minus 2 over 2, which is 3 over 2.
Oh, yes, okay.
Which option?
It's 3 over 2. Oh, which option is it on the, so, let me just...
If you want to, you can write this nicer. Okay, so I can write this as 5 over x squared. And I can write this as 15 over 2 x to the 3. Here we go.
Okay, so I think it's, it would be number 1? No.
Option 1, yes.
Yeah.
There we go.
Okay.
Question 25, what do we do?
What is the marginal cost of radios
Exactly.
are manufactured? So marginal cost...
marginal cost comes from what?
I actually don't remember.
Okay,
Oh,
marginal
but
anything comes from the derivative of the total function.
Okay.
Derivative of total costs is marginal costs. Okay, it doesn't matter what it is. Derivative of total anything is the marginal anything. Is that okay?
Yeah.
Alright, so how do I get the derivative? Ooh, MC, not MR. This is marginal cost, not revenue. Give me the derivative.
Is that a 3? So it's 6q squared to the power 2 minus 2q plus 80.
Fine. Now what?
You need to brackets. No, you don't. Yes.
What is the question asking you to do?
What is the marginal cost if 10 radios are manufactured?
So
we've got the quantity, so we just got to replace the quantity with 10.
exactly.
Okay. And that's it. Okay. And 2 plus 80. 660.
Yes.
Oh, okay.
Right, 26.
Find the derivative.
Again, they've given you a lin, so you need to refer to page 335, whereby we're looking at rules relating to lins and logs. Okay, this is obviously log base E is lin. Okay, so log base E is lin. Here you've got find the derivative of this function. Okay, so the function is ln 3x to the 5. That's what you've got. Okay, so let's write that down. Ln, so d over dx is the derivative. We're deriving ln 3x to the 5. That's what we're looking at. Okay, what does the rule say? When I have f of x, f of x is the function. So if I have ln x, what does that give me as the derivative? F dash x is 1 over x. Right?
Okay.
So what's the answer going to be?
One over 3x. Okay. We'll just...
Which option?
Okay. Option 4.
There we go.
Okay. No, that's simple enough.
Okay. Alright, 27. Okay, this one looks quite tough because we're going to discuss the chain rule now. Okay, it's challenging because you need to do 2 steps to get to the right answer because you've got a square root here, which is problematic. Okay, so I am going to asterisk 27. That's the tough one. Okay, well, there were a few tough ones, but the others weren't so bad. This one's quite long.
Okay.
It's difficult because you've got the square root of a term here in the denominator.
Okay.
Okay, so there's a few steps that we need to do, right, for 27. Right, so I'm going to write 27. I need more space to do this. F, what is the function? 3x root
1 minus 2x power of 2.
Yeah, squared. Okay, dx.
Great.
Okay, so you're trying to, how can I say? You're trying to get the function from the derivative. Okay, because remember, integration is the opposite of differentiation. That's what they want here.
Yes.
And they want you to evaluate the integral. So after having substituted everything in, I'm then going to evaluate what those numbers are.
Okay.
Okay. Alright, so if I'm going to look at the actual integral, I need to apply the rule. So I can't differentiate this as it stands because of that root sign there. Okay, so because I've got that root sign, it creates a problem. Okay, so the chain rule that they describe in chapter, chapter 6, differentiation and applications. Well, the chain rule is actually more for the integration than it is for the differentiation. So that's actually a different chapter. Let me just get the chapter reference. Chapter 8. Okay, but I'll explain what it is in this example. Right, so I can't find the integral of that because I've got a term underneath the square root. So I need to make the 1 minus 2x squared equal to u. Okay, they just use a random variable. It's like a dummy variable just to manipulate the mathematics in the original question. Okay, because working with u is easier than working with that whole bit there. Okay, so if I've got u equals 1 minus 2x squared, okay, I want to know what du over dx is. Okay, so I'm deriving u in terms of x. Du over dx is going to be minus 4x. Okay, so now I can solve for dx. Dx, if I take dx to the right, I'll have du over minus 4x equals dx. Okay, so I took the dx to the right, I took the minus 4x to the left. Okay, so do I have a term that represents dx? Yes, I do. That represents dx. So now I can plug all of that into this original question. Okay, so the integral of 3x of root u of dx. What is dx now? Dx is du over minus 4x. Okay, can I cancel the x's? Yes, I can. That helps so much because now I've got rid of the fancy numbers or the variables and I'm just left with u. Okay, so now I'm looking at the integral of u to the half du. Can I find the integral of that? Very easily. Okay, because now I write down the number, I write down a half, I add 1, I divide by 1 over 2 plus 1, and that gives me the plus c, obviously. Okay, so let's work that out. U to the 3 over 2 over 3 over 2. Okay, a divide over a divide is a times. Okay, so I can swap that around. So 3u to the 3 over 2 times 2 over 3 plus c. Okay, so that 3 will cancel with that 3. I'm left with 2u to the 3 over 2 plus c. There's my function. Now, what was u? U was this. Okay, so u goes back in. Brackets 1 minus 2x squared close brackets to the 3 over 2 plus c. Is that what I had? Yeah, 1 minus 2 to the x squared. Yes, that is right here. Yeah, 1 minus 2x. Okay, fine. Okay, now what do? Substitute in. What do I want to substitute? 1 and 0. Okay, so this is my f of x now. That's my function. So f of 1 and f of 0. Okay, so let's put in a 1 and a 0. Okay, obviously 1 squared is 1. Then I'll have 1 minus 2, which is minus 1. Minus 1 to the power 3 over 2 gives me, what is that? Oh, hold on a sec. 2 brackets minus 1. That's giving. Did I write that down right? I'm getting a maths error because of the negative. I've left the sign out somewhere. Where's my sign? I made a mistake with the sign here somewhere. Where's the sign now? Oh, there's it. Do you see it? There's it. There's the mistake. Here's the minus 4. Okay, So if it's minus 4, it should be minus 3 here. Minus, I forgot a minus here, I forgot a minus here, I forgot a minus here, and I need to put a minus here. Okay, that's better. Okay. Right, so then it should come out as a positive number. Minus 2 brackets. Minus 2. Because u was negative here. Let's check that. Yeah, du over dx is minus 4x. So dx is du over minus 4x. Okay, so dx went in. There's dx, that went in. So that became negative 4. So that becomes a negative 3. Because this was 3 over 4. I cancelled the x's. I'm left with minus 3 over 4. Okay, I'm going to redo what I did here just from this step onwards. Just need to fix this. I left out the minus, so made a bit of a mistake there. Okay, so let's just rub that out. Okay, so that was all fine except, okay, this was not fine. Okay, so let's start back where I had the du. Okay, so I had the right dx. The dx here was du over minus 4x. Okay, so that goes in, that's fine. Du over minus 4x. Then I said we cancelled the x, which was right. Then I'm left with 3 over minus 4. Okay, so I can leave the minus there. I'll just put 3 over 4 there. And then I've got u to the 1 over 2. Okay, that's fine. Alright, so now I need to do the integration. Okay, so the integration says I need to add 1 to both sides. Okay, so I'm going to have minus 3 over 4. Okay, I'm working out the integration, so that's going to be plus 1. So u 1 over 2 plus 1. Then this will be divided by 1 over 2 plus 1. Okay, so now we've got negative 3 over 4 u to the 3 over 2. Okay, divide by 3 over 2. Okay, plus c. Alright, so now I've got the divide becomes a times, so negative 3 over 4 u to the 3 over 2 times 2 over 3 plus c. Okay, so now I can cancel that out. Okay, so that cancels with that cancels with that, and I'm left with the 2 here. Okay, so that gives me, negative 1 over 2 u to the 3 over 2 plus c. Okay, so now we can put in the u. What was the u? The u was 1 minus 2x squared. Okay, so u here is 1 minus 2x squared to the 3 over 2, negative 1 over 2. Oops, ooh, textbook fell. Okay. Alright, so that's the minus 1 over 2 brackets 1 minus 2x squared to the 3 over 2 plus c. Okay, and I'm looking for what here? I'm looking for the f of 1 and f of 0. Okay, so if I plug that in, what does that give me? Does it still give us a negative number? Can you just check that quickly with the calculator?
I get 0.25, but I might have, wait, I might have done it wrong. Oh. Two. Minus 1. Minus 1.5.
Minus 1.5.
Yeah, is that right?
The answer is option 1. What number is this? 27. Yeah, option 1, 0.5.
Oh, 0.5. I might have done it wrong.
Okay, let me type it in. Let's check. Okay, so 1.
Minus 1.
Yeah, because the bracket stays there. This 1 minus 2x squared must stay there because that's the u, and du was that. It was a minus. Yeah, it was a minus. It's 1 minus 2x squared, which is fine. And then we had the 3x, which we cancelled when we put in the du. Yeah, that's also fine. Why isn't it working? Okay, so we had the right, let's just check the working here. Okay, so I had this, 0 to the 1 to the 3x du over 4, that's fine. Okay, that one's right there. This point here is 3 over 4 u to the 1 over 2, which was the variable. Then we had to substitute in, and that gave me a half. This was a half to the 1 minus 2x squared. Yeah, that looks fine. That was the substitution in. Um, 1 over 2. Yeah, I think it's just the substitution. Is it not working out? If I put a 1 here, what is 1? 1 squared is 1, minus 2 times 1 is 2, 1 minus 2 is minus 1. Minus 1 to the power 3 over 2, that would be undefined. It would be undefined. If I put in a 0 though, the other half is 0, 0, 1 minus 2, brackets, 0 squared is 0, so that's a 1. Okay, so 1 to the power 3 over 2 is 1. So then minus a half. Yeah, no, it is working out. You do get minus a half here. Okay, so this is undefined.
Okay.
Undefined. And then this comes out to what? Negative 0.5. So this is undefined, so you cannot calculate a negative number, because when you substitute a 1 in here, then you've got 1 minus 2 brackets 1 squared. Okay, the bracket becomes negative. You can't find a square root of a negative number. It gives you an undefined answer. Right, so then if I'm looking at f of 1 minus f of 0, you don't have an answer for f of 1, but you're subtracting f of 0, which was negative 0.5, which is 0.5. Yeah, so it was right.
Okay.
Yeah, it was just the first bit which was undefined that we cannot solve for, because the number gives you a negative number, which is an irrational answer. Okay, you can't find a square root of a negative number. If you put that into your calculator, the calculator gives you an error.
Okay.
Yeah, but if you put in the naught, yeah, the naught should give you that answer. If you put in naught here, because naught squared is naught, minus 2 times naught is naught, so it's 1. The cube root of 1 is 1, minus a half is minus a half. Yeah, so minus a half is 0.5. Yeah, so it was fine. So I'm looking for a mistake, but it was just the negative that I did leave out. Yeah, which we had to fix. Did I fix it? Yeah. Okay. There's the negative. There's the negative. Okay, that's fine. Okay, sure. Yeah, that was the tough one in this paper because it required the chain rule. That was the main thing. Okay, how do you do chain rule? I did it here. You have to make it let equal something. Okay, and then substitute in to get the answer, and then you just keep going through the steps. Right, the difficult bit is this, because that was the chain rule. Okay. Alright, so that was 27. 28?
Calculate the consumer surplus for the demand function.
Yeah. So how do I find consumer surplus?
We just did this.
Yeah, so how do we get consumer surplus?
So we first need to we have the price, so we've got to plug in the price.
Yes, you need to find the
Q
area under the graph.
Yeah, so
okay, but
that
do you
is
have a linear function?
do I? Oh, so
maybe you need the function first.
Okay.
Okay, so is this a straight line?
No.
No, it's not. So it's going to be a curve like that. Okay, so what must I use here? I need to use integration. Okay, so I need to integrate this particular question, which we're going to do. So I need to find the integral of the function first before I can work out the surplus. Okay, so the first step is obviously to get the quantity. Right, so what is price? 10. So this is the easy bit of the calculation. Okay, 40 over Q plus 3. Take this to that side. Okay, so 10 times Q plus 3 equals 40. So I'll have 10Q plus 30 equals 40. 10Q equals 10, Q equals 1.
Wait, hold on. Where did you get... Oh, okay, sorry. Yes, okay. Yes. Fine.
Okay, I need to make some space here quickly before we can carry on. Okay, so Q equals 1. Right, so I now know what the quantity is. Okay, quantity is 1 when price is
10.
10, exactly. Okay, now I need to work out the area under the graph because I'm looking at the integral of price, because price is the formula for demand. Okay, so the integration from 0 to 1, because that's quantity. Okay, what was the function? 40 over Q plus 3.
Plus 3.
Okay, and this will be dq. Right, because I've got the area under the graph, and because this is a curved graph, right, what the derivative does is it gives you the it's the min or the max, but now here we're moving backwards. So we've got a function that we need to integrate in order to get the original function that gives us the area under the graph. Okay, because that's what we're trying to get. So we're trying to go from derivative back to function. Okay, because the function is what gives us the area under the graph. That's what I need to substitute in, which is the naught and the 1. Okay, for the 40 over Q plus 3 dq. Right, because this is a curved graph for consumer surplus, you also need to subtract P0 times Q0. Okay, so your price 0 times your Q0. Obviously, my price 0 here is what? I need to check. What is my price 0 here? Price 0, we need to put in. What is the price 0? Price 0 was 20. Okay. No, not 2010.
Wait, yeah,
That
I
was
thought,
the
yeah.
40. 40 and 10 was 30. Okay, so yeah, that's 10. So the price 0 was 10. And the quantity was 1. We worked out quantity. Okay, so the price and the quantity. Right, that's something additional that you need to include for that bit. Okay, then we can integrate this thing. Alright, so now I need to integrate this bit over here. Okay, so what am I doing? I'm moving backwards. Okay, remember earlier we spoke about page 335? Okay, what did 335 have? 335 had this. F of x, 1 over x, is ln x. Okay, if I'm doing integration, which way am I moving? Am I moving back or forward?
Yeah, backwards.
I'm moving back. So I'm taking the I'm taking the derivative and I'm working out the function. That's integration. Okay, so I'm going from that to this. Okay, so what do I have here? I have a number over q plus 3. So I'm moving back to that, ln x. So the integration of any number over x is going to be the 1 over q plus 3. Well, 1 over q plus 3, the integral would be ln x. Is that okay? Let me write that down here. It might make more sense. Okay, so let me write this down. 1 over q plus 3. I'm moving which direction? Back. So what does that give me? It gives me ln q plus 3.
Okay.
Does that make sense?
Yes.
Okay, so that's what I'm looking at here at the bottom. Okay, which is the function. So that's the function of that derivative. Okay, ln q plus 3. So let's put that in. Ln q plus 3. Okay, the 40 was a constant, so the 40 stays there. Okay, and then I'm going to have, okay, well, dq drops because now you found the integral, and then you'll have minus 10 times 1 is 10.
Okay.
Okay, so that's what I've got over there. That's the integral. And I'm looking for 0 to 1. Okay, so let's put that in. So now I'm looking at the f of 0, and I'm looking at the f of 1. Right, so on your calculator, we need to type in 40 ln brackets 1 plus 3. What does that give you?
3. I get 55,45.
Yeah, 55,45177. Okay, then I need to put in 0.
Oh, do you minus the 10 or not?
No, the 10 you minus afterwards.
Afterwards, okay.
Okay, so what does that give me?
So I've got on 40.
That's a 3. 43.
Yes.
Okay, so then I need to subtract the big one minus the small one. So this minus that.
11,51.
Okay, minus the 10. 1.51.
Ah, okay.
Okay. Right, because we subtracted the quantity. Right, quantity here was 10 times 1. Yes. Okay, so 10 times 1, I had the 55,45 minus the 43 less the 10, 1.15. Yeah, that's
okay.
there. Okay, good. Okay, so yeah, some tough ones here. So maybe I can asterisk that one as well, because that was consumer surplus, but you had a non-linear function. So then you just had to apply the derivative again to get back to the function.
Okay, that one didn't seem too bad, so we'll see.
Alright, 29. What must I do here?
Calculate the cost of employing the first 7 labourers.
So?
Oh, the marginal labour cost function is given.
They've given you that, yes. So what do I do?
I actually don't know.
We need to work out the total cost, right? Okay, because they said here the marginal labor cost. So marginal means the next laborer. They said calculate the cost of employing the first 7 laborers. So from laborer 0 to laborer 0 to laborer 7.
7, okay.
Okay, 3 plus 4L. Okay, because remember marginal. Now I'm going backwards. Okay, remember we spoke about total labor cost, total labor costs. Okay, if I get the derivative of total labor cost gives me what? Marginal labor costs. Okay, so marginal labor costs, integral of marginal labor costs will give you total costs. Okay, so you're integrating 3 plus 4L. That's what I'm doing. Okay, so let's do that. So total labor costs equals, what's the integral? Well, 3, I put an L here. Okay, because what's the derivative of 3L? 3.
Okay.
I'm moving backwards.
Yes.
Okay, then I want the 4L, 1 plus 1 over 1 plus 1 plus C. Okay, so 3L plus 4 over 2 is 2L squared. Okay, that's the TLC, total labor costs. Okay, what did they say? Calculate the cost of employing the first 7 laborers. Okay, so we need TLC 7 and we need TLC 0.
Right.
What is TLC 7? 7 times 3 is 21. 7 squared is 49. 49 times 2 is what? Ooh. 49 times 2.
98.
98 plus 21.
119.
119. Okay, TL 0. Okay, 3 times 0 is 0. 2 times 0 squared is 0. 119.
Oh, okay.
Okay, you're subtracting the one from the other. Okay, total labor cost 7 minus total labor cost 0.
Okay.
Okay, so you were working backwards. You had to work out the function. You had to integrate. You had to integrate marginal to get back to total. Make sense?
Does, I think.
Okay, yeah, we're moving from marginal back to total. Okay, so if I derive the total labor cost function, I get the marginal. Okay, the derivative of total labor cost gives me marginal labor cost. So if I want total labor cost, I need to go backwards. So I'm taking the marginal labor cost and I'm getting the total function from the integration. Okay, because integration gets me back to the total, which is what I did here. So my total labor cost is what I've worked out. Okay.
Okay, yes.
Alright, then 30. Okay, 30 we saw one previously that was looking at graphs.
Mm-hmm.
What do they want? Maximum. Where does the maximum occur? At 3 points. Maximum is the point furthest from the origin. So there's a possibility 0 and 20. Here's a possibility. Okay, what is that? 15 and 5.
Is okay.
5 and 15, wrong way around. X first, then Y. And then another point over here, 12 and 5.
6. I think it's 6.
Is it 6?
Yeah.
6, not 12. 6 for this one as well. It's 6 there and 6 there.
Mm.
Okay. 6 and 12. Alright, so what are we doing? We're working out the maximum. Okay, so let's put in 0 and 20 here. So if I put in 0 and 20 here, what do I get? It's 0 plus 20 times 20 is 400. Okay, so I have that for that point. Make sense?
Yes.
Okay, then 6 times 6 is 36. Plus 20 times 15. What is 20 times 15? 300. 336.
Yes. Yep.
Okay, and then the other one is 6 times 6 is 36. Plus 12 times 20. What does that give you? 12 times 20 is 240.
240.
How much?
So 276.
276. Okay, which is the biggest amount?
400.
400.
Oh, there we go. Ah, okay.
Yeah, 400 was the biggest value here.
Okay, perfect.
Okay, so that's with looking at minimum, max. I think the previous one we looked at was minimum, if I'm not mistaken. I can't remember now. Yeah, but we looked at one or two of these where we had those graphs.
It's actually quite a nice one.
Yeah, it's not too bad because it's interpretation. They've drawn the graph for you. You're just looking at the maximum point, which is the point furthest from the origin. Okay, so the points that are on the edges there. That's the maximum, that's the maximum, that's the maximum. Those are potential maximums. Okay, so we're trying to work out which value is the biggest. Okay, and then that covers that past paper.
Perfect. Okay.